Hi there, and welcome back to the channel. In this video, we're going to discuss the wet leg level transmitter. So let's start with the basics. A wet leg level transmitter is used to measure liquid level in pressurized vessels, typically in closed tanks like boilers, evaporators, or separators, where vapor pressure above the liquid surface would otherwise distort a standard differential pressure reading. In a wet leg setup, both the high pressure and low pressure sides of the differential pressure transmitter are connected to the vessel. But here's the twist. The LP leg is intentionally filled with a reference liquid, usually water or a compatible fluid, creating a wet leg. This ensures the LP side always sees a stable hydrostatic pressure, regardless of vapor fluctuations. In a pressurized vessel, the vapor space above the liquid can exert significant pressure. If you connect the LP side directly to that vapor space, your transmitter will read the difference between the liquid level and vapor pressure, which is not what you want. By filling the LP leg with liquid, you isolate the transmitter from the vapor pressure changes. The transmitter now compares the HP side pressure from the liquid column inside the tank and the LP side pressure from the static liquid column in the wet leg. This gives you a clean differential pressure signal that correlates directly to liquid level. Let's break down the physical configuration. The HP tapping is connected to the bottom of the tank where the liquid pressure is highest. The LP tapping is connected to the vapor space in the top of the tank, but routed through a filled reference leg. The reference leg is a vertical pipe filled with liquid, typically the same fluid as in the tank, or a compatible substitute. The DP transmitter is often mounted below both tapping points, often at or below the bottom of the tank. The transmitter reads the pressure difference between the HP and the LP sides. Since the LP side is filled with a known column of liquid, its pressure is predictable and stable. Okay, let's get technical. The transmitter calculates the differential pressure as dP equals PHP minus PLP, where PHP is the density of the process multiplied by gravity multiplied by the height of the process in the tank, and PLP equals the density of the reference fluid multiplied by gravity multiplied by the height of the reference fluid. Assuming both fluids are the same and the reference leg height is constant, the transmitter output becomes a direct function of the process level. But if the reference fluid is different, say heavier, you must compensate for the density difference. This is where calibration and zero suppression come in. Because the LP leg is filled with a liquid, it exerts pressure even when the tank is empty, so the transmitter must be calibrated and zeroed to treat this baseline pressure as zero level. This is called zero suppression. You shift the transmitter's 0 point upwards to account for the wet leg pressure. If the wet leg is 2 meters high and filled with water, the LP side sees about 0.2 bar. The transmitter must treat this as the zero level. So the sealed legs should be checked for leaks regularly. If the reference fluid is denser than the process fluid, it can skew readings, so always calibrate with the actual fluid densities. If zero suppression isn't set correctly, your readings will be offset. Always verify the wet leg height and fluid density during commissioning. If the wet leg fluid is exposed to temperature swings, its density can change, so always use insulated lines or temperature compensated transmitters if needed. Let's take a real world example. So imagine a closed boiler drum with steam above the water below. You want to measure the water level without being affected by the steam pressure. The HP side taps into the bottom of the drum. The LP side taps into the steam space, but through a water-filled reference leg, reading the differential pressure. As the water level rises, the HP pressure increases. The LP pressure stays constant due to the wet leg. The transmitter output increases proportionally, giving you a reliable level signal. If you would like to know more about the operation of wet leg level transmitters, please see the link in the description below, where you will be taken to a free download on our website that gives you much more information than we have presented here. We have many free downloads on the website, so please take a look around. We also have some training courses available now, so please stay tuned for more of that as well. Again, the link is in the description below, so please take a look at that and check back regularly for more videos. Thanks for listening.